All right, welcome back, class. This is 9.3b, inverses and graphing logarithmic functions. So in yesterday's video, if you watched that, or in class, I may have noted that exponential and logarithmic functions are inverses. So that's kind of what we're going to be looking at, and then graphing these logarithmic functions. When we review, I'm going to go over a couple of these since they should be refreshers. Log base 4 of 16 equals x. The way we do it is we go this way, and that becomes 4 to the x equals 16. And then what we're solving for is x. So this one is kind of mental math. 4 to what power is 16? That would be then where x is equal to 2. So that's what we're looking at here. Let's now look at one where we're gonna maybe do a root function. So we go a whole number that's bigger to smaller. So this will become 8 to the power of x equals 2. So we see that we need a root because we're decreasing in a value here. So if we look at the whatever root, the x root of 8 equals 2. Well, now it becomes a little more clear because we need, 3 factors of 2. So x is going to be a fraction where it's the third root because we need that to be a fraction to then become the third root. So that's what we're kind of looking for with these review problems. This one here, I guess I will go over a couple. This is 4 to the x equals half. So we see that it's a whole number now, it's in a fraction, so x has to be a negative exponent. X equals negative something. So when it's now 1 over 4 to the x, because I did a negative exponent, well, we also need a root because it has to now get down to a value of 2 here. So in my mind, that looks like it's going to be, if it's 1 over the 4th root of x, so where x is now negative half, let's plug that in right here. So that becomes 4 to the negative half equals, I'm going to take the reciprocal, so it's 1 over 4 to the half. Then if we were to distribute to the top and to the bottom, it'd be 1 over 4 to the half, which as a root, since my index is 2, is the square root of 4, which is half. So then that would be right here. So think about some of those things when looking at solving these logarithmic functions without a calculator. Logarithmic inverses, if g of x is this function, log b of x, and f of x is this function, b to the power of x, we'll now see that they are inverses. And let's remember, when we did inverses 2 units ago, the output of g of f of x, when we compose them, we'll get x out. And then when we compose f of g of x, we'll get x out. So what happens here is basically these simplify, and all that's left is x. So that's good when we compose them. And the same thing over here, where we have a common base for both logs to the x equals x, simplifies, so it just equals x. So yeah, right, they undo each other, they simplify, it simplifies to just x. So that's how we can see that they're inverses. Again, down here, reiterating. So a sample example here, let me just flip my notes through. So it's 10 to the power of log base 10 of x. There's an implied 10 here. So now we see that, like in this one, they both have a base of b, which is 10 to the x. So that simplifies to just x. So then those would be inverses right there. How about this one? Log base 5 of 125. So it kind of looks like this one, but we can manipulate 125 to be the same base as 5. Log base 5 of 125 is the same thing as 5 to the power of 3x. So now we see that 5 cubed is 125. Those then simplify 3x out. So it's kind of like scaling our base by a factor of 3. Try it out, find the inverse. So to find the inverse function, what we would do is we would first switch our x and y. So that's going to be the first step. Switch x and y. 1, switch x and y. So that becomes x equals log 8 of y. Now we're going to go through the same steps we took in yesterday's lesson and in the review, where now we do, it's log base 8 of y equals x, so it's going to be 8 to the power of x equals y. And that's now our inverse. We could kind of write this as y inverse equals 8 to the power of x. This function and this function are inverses. That's what we just found. Let's do it over here. Rewrite x and y. So it's x equals natural log of y minus 3. Again, your base with the natural log is e. So I'm going to write that. It's implied, e. So then when we work through it, it's going to be e to the power of x equals whatever inside the parentheses here. So that's y minus 3. And we're trying to solve for y because our inverse function is going to be a y equals function. So what we can do is we can add 3 to both sides. So we get e to the power of x equals y plus 3. Look at that, plus 3. So this is the inverse of this function. And if your first step is to rewrite as x equals, you're switching x and y. Your second step is to write it as an exponential function because exponential and logarithmic functions are inverses. Find the inverse, so more practice here. Again, we're going to switch x and y. X equals log base 9 of y. So we're going through the same steps we've been doing. 9 to the power of x equals y. And that's it. That's the inverse function of that one on top. Let's see here. Okay, so first I'm going to rewrite x equals log base 7 of 49x. And what I'm already going to do is I'm going to rewrite 49 to the power of x as a base of 7 because we want those bases to be the same. So that becomes 49 is 7 squared. Oops, that's y now. So now we see that our bases are the same. Log base b of b. So these simplify. Therefore, x equals 2y. And then finally, to get y by itself, we can divide both sides by 2. So x divided by 2 equals y. That's the inverse. Okay, so log base half of x equals y. Before I take that step, I'm going to rewrite as x equals log base half of y. Now I can go through, so that's half to the power of x equals y. I don't like where that equal sign is. I want it to be clear that that's half to the power of x equals y. Now it's the inverse. If it's a log, the inverse will be an exponent, and vice versa. Again, natural log. My common base is going to be e. Now I can rewrite as x equals natural log e of y plus 2. And then I can go through those steps. So it's e to the power of x equals y plus 2. We want y by itself. So then that becomes y equals e to the x minus 2. What I did is I subtracted 2 from both sides, and then I wrote it as y equals. And so I hope you notice that e to the power of x and the natural log of whatever our solution here is here, those are inverses. Again, okay, look. Natural log. You see natural log, you put e down there. Then you switch x and y to find the inverses. E of y minus 1. Let's go through it. Boom, e to the x. equals y minus 1. We want y by itself, so we want to add 1 to both sides. E to the x, plus 1. Plus 1 equals y. One more here. This one rewrite as x equals log base 1/4 of y. So that's a 4th to the power of x. Do that, equals y. All right, looks good. Those are all inverse functions. Graph of f and f inverse for b greater than 1. So this function right here, this is what we did at the beginning of the unit. This is an exponential function, b to the power of x. The inverse inverts across the y equals x axis, or the y equals x line. That's what this line is, and that's what we learned about inverse relations. You can see that it's symmetric over that line, and this is the inverse function of f of x, which is the logarithmic function. Now, it's also the same when b is between 0 and 1, so a decay model. This is a growth. This is the inverse. This is a decay. And then this is an inverse. It may not look like it, but it is a reflection over this line. The graph, yep, right, is a reflection of the graph of x in the line y equals x. The graph of y equals log b of x minus h plus k has the following characteristics. The line x equals h has a vertical asymptote. Okay, when we looked at exponential functions, like this one, or the decay model, I'm going to emphasize it. I'm going to use orange. This one, or this one. These have horizontal asymptotes right here. So that means your inverse, I'm going to use a different color, your inverse function, this one, and now this one in pink, are going to have a vertical asymptote, which would be here and here. So it says x equals h has a vertical, or is a vertical asymptote. When it was y equals k, your inverse relation now is x equals h, vertical asymptote. And we'll show that while graphing. The domain is x greater than h, and the range is all real numbers. So you can see how the inverse relations, things kind of switch, because x was all real numbers for the domain, and y was greater than k, so that's where the inverse comes in. All right, so let's look at some graphs. State the domain and range. When we're graphing, we're going to want to take some steps. What we can do first is look at the shift. So my shift then, in this case, would be minus h plus k. So there is no k and h. So that would be 0, 0. This is, again, your new origin. That is similar. And then you could draw your x and y axis. It's at the origin, so it's not necessary. Your next step that you should do, number 2, is rewrite it so that it's y equals log base 3 of x. So this becomes y equals log of 3 of x. And now do those steps like we did in yesterday's lesson, or the review, or to find the inverse. So it becomes 3 to the power of y. We want it as an exponent, equals x. Okay, from here we're going to make a table. And since it's the inverse relation for x and y, for exponential functions, we did -2, -1, 0, 1, and 2 for x, because it was in the exponent. Now we see y is in the exponent, and it's the inverse, so we're going to plug those values in for y. -2, -1, 0, 1, and 2. Again, we're taking our base to that power of whatever y is. This is my y. So this becomes 3 to the power of -2. So this is pretty familiar. You take the reciprocal. This is 1/9. That's my, well, since it's the inverse relation, it is my output. It looks like my input there. This is 3 to the power of -1, which is 1/3 to the first. So this is 1/3. I should be clear. This is kind of where we're at. My lines aren't really straight. This is 1, this is 3, and this is 9. Those lines look just terrible. I'm just going to leave it. So my first ordered pair is over 1/9 and down 2. 1/9 down 2, that's right here. Hopefully you can see that it's the inverse of exponential growth. Then it's 1/3, -1. 1/3, -1. 1, 1. Looks like, or excuse me, 1, 0. 3, 1, 1, 2, 3, 1, and then 9, 2. It does look like the inverse. There's my asymptote. It's horizontal. Now, my domain and my range. We said the domain was x was greater than h. H in this case is 0. So x is greater than 0. My range now, it's going to continue vertically up and down forever. So that's y is an element of all real numbers. And then my asymptote is whatever that line is here. It's x equals h, which is 0 again. This is my horizontal line, my asymptote. That's the line x equals 0. So it's really similar to the graphing of exponential functions, which it should be because they're inverses of each other. All right, so I'm going to put it higher this time. My shift, there is no shift. There is no hk. That's my new origin. This time I will put my x and y axis. Just to be clear, I'm going to rewrite it as y equals log base 4 of x. So now we want it as an exponent, so it's 4y equals x. So I can do my table. Again, you want your outputs to be -2, -1, 0, 1, and 2. So that when we take our base, 4 to the power of -2, we get our x values here. That becomes 1 over 4 squared, so 1/16, 1/4, 1, 4, 16. That should all be reviewed, taking the base to the power of negative or positive exponents. Since there's no shift, I'm going from my origin, so 1/16 down 2. That's right here. 1/4 down 1. Let's see, 1, 0. 4, 1, 1, 2, 3, 4, 1, and then 16, 2 is going to be way off. It's really fast growth. And then what's my domain? So this would have been number 3, my table, for domain and range. Domain, x is greater than what? Well, whatever h is. H again is 0. My range, y is an element of all real numbers. I hope you can see that on the graph. And my asymptote, x equals h, in which case it is 0. And so it's still a growth function because my b, which would be 4, is greater than 1. If it was less than 1, it would be a decay. So it would slowly decay. It would still be greater than. If it was negative, it would reflect over this y-axis or this vertical axis. Okay, now we do have a shift, so let's label that. Again, it's the opposite of h, so that's 3, and we keep the sign for k. This is my new origin. So that's 1, 2, 3, 1. I'm going to draw this here. To rewrite it, oh, it is as y equals. Well, I still will, just so I can do it down here. Log base 4 of x minus 3 plus 1. So that's 4 to the power of y equals. And for our table, we just want to the power of x. And I hope that that's clear then. So equals x. It was the same thing for our exponential growth. We disregarded h and k because we already have our new origin. So those values, -2, -1, 0, 1, and 2, we're taking 4 to that power. 4 to the -2 power equals 1/4 squared. Again, so these should be familiar. If you need to pause and take a look at it, do so. 1/16. So from our new origin, we're going to go back 1/16, or excuse me, To the right 1/16, down 2. 1/16 down 2. 1/4 down 1. 1 0. 4 1 1 2 3 4 1. And then, oh, look at that. That's 16. 16 2. Again, that's way off the graph. There's my asymptote. So my domain, this is number 3. For domain, x is greater than, x values are increasing, greater than my asymptote of h, which is 3. And my range, again, y is going to be an element of all real numbers. And then what's my asymptote? It's x equals that line of h, 3. And you can see it pop up here, 3, pop up in my shift right there on the graph. Okay, so it pops up a couple times again. All right, one more here. Hopefully you're kind of feeling comfortable with it at this point. My shift is going to be 1, 2, new, origin. So that's 1, 2. Put my little horizontal and vertical axis. Rewrite y equals log base 2 of x minus 1 plus 2. I guess I could just write log base 2 of x just to be clear that we want it to that power. So that's 2 to the y equals x. Now we can do my xy table. -2, -1, 0, 1, and 2. So we're raising 2 to that power because that's my base. So that's half squared. So that's a fourth, half, 1, 2, and then 4. Oh, also, with these graphs, there won't be an A that will vertically stretch or shrink it, just to keep it simpler for now. So there will be no AX column. So from my new origin, my first ordered pair, my first point is 1/4, -2. 1/4, -2 is right there. Half, -1, 1, 0. 2, 1, and then 4, 2. 1, 2, 3, 4, 1, 2. So all of these were still growth, and they're positive. So that's nice, where now my domain is x is greater than h, which is 1. My range is y is an element of all real numbers. Notice how they're inverses of what they were for the growth, or excuse me, the exponential functions, whether it's growth or decay. And my asymptote is x equals whatever this asymptote is, because this function will never touch it. It'll approach it forever. That line is x equals 1. Okay. Hopefully the inverse relations and logarithmic functions are starting to make a little more sense. Graphing should go well. I think you've had practice with that. And then let me know if you have any questions, and we'll be solving next time. So